I'm going to show you very quickly Omniverse in the cloud.
Let's take a look at the Omniverse cloud. So this is just a web browser, and we're looking now into Omniverse Factory Explorer. It's running 10,000 kilometers away in our Santa Clara headquarters, and we're leveraging the power of our data center now to visualize this factory floor. A cloud application, so we can have multiple users collaborating. We have this task to perform. We need to move this object, so we can have Eloise just go ahead and grab that conveyor belt, move it over, and as he does so, you'll see that it's accurately and completely in real time.
So cool. This is in California, 6,264 miles away, or something like that. 34 milliseconds by speed of light one way. And it's completely interactive. Everything is ray traced. No art is necessary. You bring everything, the entire CAD into Omniverse, open up a browser, bring your data in, bring your factory in. The lighting just does what the lighting does. Physics does what the physics does. If you want to turn off physics, you can. If you want to turn on physics, you can. And multiple users, as many as you like, can enter the Omniverse at the same time and work together. One unified source of data across your entire company. Just now, it was humans interacting with Omniverse. Humans interacting with Omniverse. In the future, we'll even have a generative AI, and AI interact with him in Omniverse. I'm going to show you now how we're going to use Omniverse and AI here in Taiwan. And we're going to use it for manufacturing. We're going to use Omniverse to teach an AI. And then we're going to use Metropolis, our AI deployment, edge deployment system, to deploy the AI. Okay, run it.
The $45 trillion global manufacturing industry is comprised of 10 million factories operating 24/7. Enterprises are racing to become software-defined to ensure they can produce high-quality products as quickly and cost-efficiently as possible. Let's see how electronics manufacturer Pegatron uses NVIDIA AI and Omniverse to digitalize their factories. In Omniverse, they start by building a digital twin of their factory, unifying disparate 3D and CAD datasets to provide a real-time view of their complex factory data to their planners and suppliers. In the cloud-native digital twin, planners can then optimize layout virtually before deploying changes to the real factory. The digital twin is also used as a training ground and data factory for Pegatron's perception AIs. They use NVIDIA Isaac Sim, built on Omniverse, to simulate and optimize their fleet of mobile robots, which help move materials throughout the facility, as well as the pick-and-place robotic arms that assist on production lines. In the fully operational factory, Pegatron deploys automated optical inspection, or AOI points, resulting in AOI performance that is 99.8% accurate, with a 4 times improvement in throughput. With software-defined factories built on NVIDIA AI and Omniverse, manufacturers can super accelerate factory bring-up and minimize change orders, continuously optimize operations, maximize production line throughput, all while reducing costs.
Did you see that? The whole factory is an Omniverse. It's completely digital. What you just saw is basically every factory in the future will be digital, of course, first. Every factory will be a robot. Inside the factories, there will be other robots that the factory is orchestrating. Everything that moves in the future will have artificial intelligence and will have robotic capability. So this is Isaac AMR. It includes a chip called Orin. It goes into a computer, and it goes into the NVIDIA Nova Orin, which is a reference system, a blueprint for AMRs. This is the most advanced AMR in the world today. And that entire stack has been built, and let's take a look at it.
To improve productivity and increase worker safety, factories and warehouses are migrating away from manual forklifts and guided vehicles to full autonomy. NVIDIA Isaac AMR provides an integrated end-to-end solution to deploy fully autonomous mobile robots. The core of the solution is Nova Orin, a sensor suite and computing hardware that enables mapping, autonomy, and simulation. Nova's collection of advanced sensors speeds the mapping process, leveraging our cloud-based service to generate an accurate and detailed 3D voxel map. This 3D map can then be sliced across a plane to generate 2D maps tailored for different autonomous robots that might operate in a facility. With these maps in place, on-robot LiDAR, or cost-effective cameras provide autonomous navigation that works reliably in the most complex and dynamic environments. Isaac Mission Control optimizes route planning using the cuOpt library. To improve operations, developers can use Isaac Sim and NVIDIA Omniverse to create realistic digital twins of the operating environment. This allows fully autonomous robots to be trained on complex tasks entirely in simulation. All operations can be fully validated using Isaac Sim before deployment to the real world. Isaac AMR accelerates your migration to full autonomy, reducing costs and speeding deployment of the next generation of AMRs.
Nova cannot tell that it is not in the reality environment. Nova thinks it is in the real environment. It cannot tell. And the reason for that is because all the sensors work, physics work, it can navigate, it can localize itself, everything is physically based. Therefore, we can design the robot, simulate the robot, train the robot, all in Isaac, and then we take the brain, Isaac Sim, then we take the brain, the software, and we put it into the actual robot. And with some amount of adaptation, it should be able to perform the same job. This is the future of robotics. Omniverse and AI working together.